All right, now let's do some static equilibrium problems. Equilibrium problems are not challenging. They're not really hard, but they are challenging. How about that? All right, in equilibrium problems, we're always going to have, let's just call it Q1, and we're going to make Q1 and Q2 positive. Here's Q2, and they're separated by a distance R. Doesn't matter whether you use R or D. So you have Q1, Q2, they're separated by a distance R. You know there will be a point in here where if you place a third charge, and we'll call that Q3, then the forces are equal. Now let's just pretend like these are positive. It doesn't matter whether they're positive or negative. The mathematics works out to be the same. If they're positive and Q3 is positive, then Q1 is going to push, let me change my color here. Q1 is going to push Q3 away, so the force of 1 on 3 is to the right. If Q2 is positive and Q3 is positive, then Q2 is going to push Q3 away or to the left. So the force of 2 on 3 is to the left. Now in an equilibrium problem, you remember the sum of the forces is 0. So F net is 0. So we want F23 to equal F13. Now let's flip over and do our equations. F23, oh, one more thing, let me back up. The distance between Q1 and Q2 is R. Let's label the distance between Q1 and Q3 as being X. So the distance from 1 to 3 is X. Now the distance from 1 to 2 is R. So what's going to be the distance from 2 to 3? Can you see that if this distance is R and this distance is X, then the distance between Q3 and Q2 is R minus X. Because they have to both add up to be R. So this is R minus X. Now, what's the force between 1 and 3? Remember, Coulomb's law states, and I'll put it up here in a funky color, the force between any two particles is K, Q1, Q2 over R squared, where K is 9 times 10 to the 9 Newton meter squared per Coulomb squared. All right, let's come back down here. The force between 2 and 3 must equal the force between 1 and 3. The force between 2 and 3 is K, Q2, Q3, divided by R23 squared. And I'm going to write it like that, and we'll plug these in here in just a second. This has to equal K, let's see, 1 and 3, so Q1, Q3, divided by R13 squared. Now let me mark out what all cancels, because that kind of makes our lives easier. K is going to cancel, and Q3 always cancel. It turns out it doesn't really matter what that charge is. Now, what do we wind up with? I wind up with Q2 divided by, now what's the distance between 2 and 3? The distance between 2 and 3 is R minus X, and this whole thing is going to be squared. And this must equal Q1, which we don't know what that is, divided by R13, which is X squared. Now I'm going to show you a cheat. All right, get all your squares on one side and all your Q's on one side. So I'm going to come up here and finish this. So X squared, all I'm doing is cross multiplying, divided by R minus X squared is equal to Q1 divided by Q2. Now here's the cheat. I'm going to put it in red. Go ahead and do the square root. When you get to AP, when you go to college, you can't do this because we have set up the problems very carefully for you. So if I were to square root both sides, and by the way, I'm going to do a real cheat. I'm going to come over here and say, let's let y equal the square root of Q1 divided by Q2. Okay, please go on and calculate this. It is going to be ugly. You don't want to be stuffing this in your calculator all the time. What does this whole mess become? It becomes the square root of x squared is x, The square root of r minus x squared is r minus x, and this is equal to y. Now this is an algebraic problem you can solve. Let's do a sample problem. And as you can see, I do plan to use a cheat. Okay, move that out of the way. A charge Q1 is negative, so Q1 is negative 6.25 times 10 to the negative ninth coulombs. A charge of Q2 is negative 3.3 times 10 to the negative ninth coulombs, are separated by the distance of, so this is my R of 80 centimeters. Now folks, I have to have this in meters, so this is 0.80 meters. Pen is not working. Okay, where could a third charge be placed so the electric force is 0? So we have Q1, and these are negative, but that's okay. Q2, negative, that's okay. And we're going to put a third charge right there. The distance between 1 and 3 is x. So we're going to write that down. R1, 3 equals x. The distance between 1 and 2 is 0.8 meters. So the distance between 2 and 3 is 0.8 minus x. And go on and put that down. So R23 is 0.8 minus x. So now, what's my equilibrium point? I know the force of 1 on 3 has to equal the force of 2 on 3. The force of 1 on 3 is K, Q1, Q3, divided by the distance between 1 and 3 squared. This must equal K, Q2, Q3, divided by R23, 3 squared. Square up there. Well, my pen, I'm sorry, when I get near the end of my board, my pen starts messing up. Now let's figure out what cancels. K's cancel. Q3 cancels. So we're left with Q1 divided by R13 squared is equal to Q2 divided by R23 squared. I'm going to cross multiply. So I know, let's see, Q1 divided by Q2 has got to equal, now R13 is x squared divided by 0.8 minus x squared. I'm going to square root both sides. And I'm going to call this y because I don't want to write out the square root of Q1 divided by Q2. It's kind of messy. So, let me switch pen colors here. Lost my pen, I tell you. Technology is great. So, x divided by 0.8 minus x has got to equal this y. We'll come up and compute the y here in a second. So, let me come up here and solve this. X is equal to y times 0.8 minus x. So let me distribute this. X is y times 0.8 minus xy. And this is, of course, just a number. So I'm going to add xy to both sides. So this is x plus xy is equal to 0.8y. I want to factor an x out. So this becomes x times 1 plus y is 0.8y. So x must be 0.8y divided by 1 plus y. Now you see, if you've already calculated this, I don't have enough room to show you that calculation. I'm just going to plug it in. So this is 0.8 times y. Now remember, y is this ugly square root of Q1, which is negative 6.25 times 10 to the negative 9th, divided by, what's Q2? Negative 3.3 times 10 to the negative 9th. And this is divided by 1 plus the square root of that mess. I'm sorry, I ran out of room. And you do, as a matter of fact, get the answer is 0.463 meters.